Okay, I'm going to look at another method of calculating the new draft having been trimmed bilge forward, and I'm using the same dimensions as the previous example, 140 by 24 by 5.4. kg of course doesn't change, and the forward end compartment the same length, watertight flat 4 metres above the keel. Calculate the final drafts. The compartment is bilged below the flat. So we need our sinkage initially, so it's the volume of lost buoyancy over intact water plane, and that gives us our new draft, 6.029. And the weight of the lost buoyancy will be the volume times density, and the volume is 2112, density, so that gives us 2165. So this is the alternate method, if you like, to calculate. So on the sketch there I've marked the fact that our L shaft doesn't change. Now I have to work out the trimming lever created by this weight of lost buoyancy. And the trimming lever is from the centre of flotation to the centre of the bilge compartment. So you can see there, from there to there is 70, minus 11 will give us 59. So our trim lever is 59 metres. So the trim moment created will be the weight times the lever, 127,735. The MCTC that we calculated, the same as the last problem, displacement doesn't change, length doesn't change, GML will be KM, L minus KG, KG doesn't change, so we need the KB and the BM. And to get the KB, because the compartment only goes up to the flat, it means that our KB cannot be the draft divided by 2. So we simply have to work out the KB, and we use the usual method, 140 by 24 by the new draft, minus the compartment, and the centre, the KB is half there. That will give us the BML, which now we can get the GML, divide, so I use the MCTC formula, displacement times GML over 100 times length, and we can get the trim. Obviously the LCF hasn't changed, therefore the trim is half and half, and that gives us our final drafts. You will notice there'll be a very slight difference in the trim moments with the two types of problem, but that's just down to rounding. When it comes to the final drafts we get pretty much exactly the same.